Welcome to this explainer. Today, we're diving into the ocean's hidden depths. We have this massive, unexplored world right here on Earth that's basically completely inaccessible to us. But that's about to change. We're going to look at some revolutionary new technology that's literally pulling back the curtain on the world beneath the waves. Let's get right into it.
So first up, why do we know almost nothing about the ocean? It's kind of a massive paradox, right? We all know how absolutely crucial this ecosystem is for global survival. It produces half the oxygen you are breathing right now. And yet our actionable data on what actually goes on down there is shockingly limited.
Now, the core problem here isn't a lack of scientific curiosity. Scientists are dying to get down there. The real issue? Access. Going down there and actually staying down there is astronomically expensive. We're surface dwellers, and the deeper you go, the more the actual physics of the environment just aggressively fight against your survival.
Which brings us to Section 1, the ocean access problem. Get this, the ocean is home to more than 90% of all life on Earth. 90%. Yet despite housing almost the entirety of our planet's biology, we are completely bottlenecked by how much time we can actually spend down there observing it. It's literally like being locked out of the biggest living room on Earth.
All right, Section 2, the blind spot zone.
When we think about deep-sea exploration, our minds immediately jump to the extremes, right? Like the Mariana Trench. But actually, the most critical, highly active, and least studied area is sitting right below the surface. We call it the blind spot zone. It sits right between 50 and 200 meters deep. At this specific depth, there's just enough sunlight filtering through to trigger photosynthesis, and because of that, life just absolutely explodes in ways we barely comprehend.
The stats on this are honestly staggering. Just think about this for a second. This one narrow band of water holds 96% of the world's reef systems, over 91% of protected marine areas, and around 72% of all known cultural sites and shipwrecks. It's the beating heart of the ocean, and yet researchers literally call it our blind spot zone. We know it's incredibly vital, but we just can't get a good look at it.
So why is this specific zone a blind spot? Well, it basically comes down to a dilemma of technology and money. For anything near the surface, say up to 50 meters, standard scuba diving is safe, it's effective, and divers can spend a decent chunk of time down there. On the flip side, if you go super deep, way past 200 meters, well, that's when it starts to make economic sense to deploy those multi-million-dollar submersibles. But that middle band, it is so awkward. It's too deep for scuba divers to hang out safely for very long, but it's considered just too shallow to justify the massive price tag of a deep-sea sub. It completely falls through the cracks of what we can currently do.
Moving on to Section 3, ending drive-by research. Because of this really awkward gap in our capabilities, we've had to rely on some pretty deeply flawed methods to study this vital zone. Until now, scientists have basically been forced into what they call drive-by research, and it is exactly what it sounds like. Even the most highly trained, experienced technical divers only get these frantic, minute-long visits to this zone before they have to turn right around and start the painfully slow process of surfacing to avoid decompression sickness.
Marine biologists are constantly venting their frustration about this. Think of it like trying to understand how a bustling city works by just flying over it in a plane once a year. Sure, you'll see the buildings, but you are going to miss absolutely everything that matters. These brief, chaotic underwater visits completely miss the behavioral details, the subtle predator-prey interactions, the real rhythm of the ecosystem. To understand a city, you gotta live in it, right? Well, the ocean is exactly the same way.
Let's look at the solution in Section 4, underwater time machines.
So how do we fix this access problem? Simple. We just don't leave. Right now, teams of engineers and aquanauts are literally building entire underwater bases where humans can live, work, and eat normally for weeks at a time. And honestly, the absolute coolest part about these habitats, they feature what's called a moon pool. Just picture an open hole right in the floor of your living room that drops directly into the open ocean. Because the air pressure inside the base perfectly matches the water pressure outside, the water doesn't flood in. Physics just politely holds it right there at the floor level. Researchers can literally drop in, observe marine life, and then swim right back up into their base for lunch.
It's wild. And the target depth for these new habitats? Exactly 200 meters. By designing these bases to be installed all the way down at that 200-meter mark, these teams are instantly unlocking total, continuous access to the entire blind spot zone. They are taking the laboratory and dropping it right in the middle of the most active part of the ocean.
If we can actually stay underwater, the entire paradigm shifts. Research that used to take years of temporary, dangerous surface diving, trying to piece together fragmented minutes of data over hundreds of risky drops, well, that can now be knocked out in just a matter of days from inside our habitats. A scientist can wake up, grab a cup of coffee, and spend 8 uninterrupted hours directly observing an ecosystem. It's a total game changer.
Because they so dramatically accelerate our ability to gather accurate long-term data, the creators of this technology literally refer to these underwater bases as time machines. They are condensing years of vital scientific discovery into mere days, completely fast-tracking our understanding of the planet's ultimate life support system. The teams making this happen all share one massive driving belief. The most paradigm-shifting discoveries on Earth are still waiting for us beneath the waves. And to find them, we absolutely need more than just remote-controlled robots. Now, don't get me wrong, robots are great, but they completely lack human intuition. We need real, living aquanauts down there in the water to observe, to react, and to make those sudden connections that a pre-programmed machine would just swim right past.
So as we finally piece together the infrastructure to permanently illuminate this blind spot zone, we are truly standing on the precipice of a brand new age of exploration. And it leaves us with one incredibly thrilling question to ponder. Once we finally move in, what incredible discoveries are waiting for us in the dark? Thanks so much for joining me for this explainer. Stay curious, and I'll catch you next time.